So, today, as I was telling, we are starting a new topic of binary star system. And what's the main motivation for study? Well, obviously, main motivation is statistics. Most of the star systems are observed binary in nature. And there are also star systems yes, like this and something like this. They also exist, but it is quite rare. But of course, using telescopes, people have studied such systems, and there we have verified our basic laws of physics. Okay, so these star systems basically are what? Playgrounds for testing our laws of physics. And through these tests, sometimes we get very valuable insights about our laws, its applicability, its limitations as well. Anyway, so, right. So binary star system. Most of the majority of the cases we have got binary stars. Now, what's a binary star system? So basically we have got two stars like this. So suppose when I am talking about general case, so they have different masses. Now, as you know, this is a star, so this means hydrogen fusion is occurring or has occurred and stopped, right? Fusion has occurred, something like that. And the masses are different, so this means that the rate of fusion or the rate of evolution is also different. Low mass star, heavy mass star, we have all discussed about it. The various evolutionary phases of low mass and heavy mass stars. So the mass is different and rate of evolution is different. Fine. So why do we study this binary star system? The question arises, what is the main motivation? There are two viewpoints, or you can say two main motivations for studying this. One is the orbital mechanics. How do they revolve around each other? Okay. From there we get valuable information about the time period, about mass, okay, and all that. That is astronomical viewpoint. From astrophysical viewpoint, we are studying this binary star system because, just for the time being, consider that this is a star which is undergoing hydrogen fusion. So what will happen during the course of the time is that because the core, after core hydrogen burning, there will be shell hydrogen burning, and as a result its shell will keep on increasing because of the effect of shell hydrogen burning, right? Its size will increase basically. Size will increase due to shell hydrogen burning. This is the new size. So you see, the star's size keep on increasing. The mass remains the same, but the overall volume increases. Now, is there any problem with that? Think of it. It is very simple to understand. You see, there are two gravitational objects, so they each have their own gravitational field. Now, if the size increases a lot, then you see that this part also, this gets closer to, as it gets closer to this object, what happens is that more and more it feels the gravitational field of this second star, and during the course of time it can happen that this mass gets transferred from this star to this star. So there is mass transfer. Okay. It can happen from all over the place, not just this part as well. So this is our main motivation of study, astrophysical viewpoint for binary star system, mass transfer. Now you must be thinking, what is so important about mass transfer? Just think of it for the time being, as if we are playing a game I've got two jars, water, unequal amount of water. I am putting one water from one jar to another and then again from one jar to another. It's a play like that. Now see what will happen. This jar, this has got bigger mass. Now as it absorbs the mass of this jar, mass transfer, through mass transfer, its mass changes. Now there are certain possibilities. Number one possibility, this mass, if the surface of this star is very hot, then as the mass gets, and this mass which is being transferred, its temperature is much lower, suppose, then what will happen? As if you are throwing some water on a pan which is hot, what happens? Evaporates, right? If more water, huge sort of, explosion sort of. So there are certain astrophysical objects, phenomena, right? Basically, nova is related to this mass transfer. This is an astrophysical phenomenon. Nova. Supernova origin is different. I am not talking about it right now. Nova. So this is yet another reason for studying the binary star system. Right. This is nova. Next, as it keeps on increasing the mass, what will happen? Its evolutionary phase will again change. It might be that it keeps on, since it is absorbing more mass, what will happen? It will decay, or the rate of its evolution will become faster, and this one will become slower. Try to understand. Initially, it was losing mass, it was absorbing mass. Then after some time, when it will stop, and this one will start evolving, and then it can happen that suppose it has become smaller and this has become larger, right? Now this one is undergoing, suppose, fusion, shell burning, and as a result its size again increases. Then what will happen? Again there will be transfer of mass from this side to this side, right? And as a result its size will increase overall because of mass transfer. Right, so see, this is very interesting. Because of the mass transfer, the evolution, the way it evolves, the entire system, it changes. Their size changes and their mass also changes. So we are going to study this thing. Another very important point. During this entire evolution, I am talking about the size, entire size, okay? Size of the star. But not only that, what do you think about the distance between the two stars? It will also change. So what we are going to do, how are we going to do this? We will talk in details. The basic idea is that if these are the two stars, then we will write down the entire gravitational field due to these two stars, taking into account their rotations. And there we will draw the gravitational contour lines. And there you will see something like this. These are the gravitational contour lines. This lobe, this one in particular, this zone, this shows that the gravitational field of this star is important in this lobe. And here, in this case, basically, in this lobe, the gravitational field of this star is important. These are the Roche lobes. This is what we are going to study. Okay, we will talk about the mathematics soon. But these are the basically Roche lobes. And now we are going to talk about mass transfer using this concept. How? So basically mass transfer means as it evolves, its size increases. Suppose its size increases like this. Now this matter is outside the influence of this star. So this matter will get what? Transferred to this star, another star system. See, so we are going to discuss about this mass transfer using the concept of Roche law. Fine. So let's now talk about the mathematics. Okay. So basic three types of binary. On what basis? Mass transfer basis. So here our main point is the Roche law, right? So this is the inner Lagrangian point L1. Okay, so these are the two masses. This mass is double of this mass in this particular example over here. So now, accordingly, we have got classified three very distinct cases. The first case is detached binary, this one, where each of the mass of the two stars, they fit inside their own respective Roche loops, as you can see. No matter what evolution phases they go through, the mass is inside the Roche loop. So this is detached binary. Next one. In one particular case, the mass remains inside its Roche loop, but in the other case, the mass fills and maybe spills somewhat from its Roche loop. So this is the semi-detached binary. And then finally, we have got the contact case, where the Roche lobe of each of the cases, each of the stars, they are filling their own individual Roche lobes, right? The matter of each of the stars, they are filling their individual Roche lobes. Any questions?